Hello everyone. Myself Dr. Rajesh Prasad. Currently I am working as professor in Akgec Ghaziabad. So my today's topic is matrix multiplication. So I am going to cover like Strassen's method using divide and conquer approach, and then second method is going to be matrix chain multiplication. So this is the outline of the talk. First is matrix multiplication general. General in the sense that why we need this topic, and like what is matrix multiplication and what is time complexity of multiplying two matrices. And after general discussion, I am going to discuss recursive matrix multiplication using divide and conquer approach. We will check whether we are having some improvement over here or not. Then the important method is the Strassen's matrix multiplication method. This is also using divide and conquer approach, but its time complexity is lower than the recursive matrix multiplication. We'll compare like Strassen's method and recursive matrix multiplication, and we'll see that this is having better time complexity as compared to other method. Then we'll talk about matrix chain multiplication using dynamic programming. So let's understand matrix multiplication in general sense, right? So suppose we have two matrices A, Aij. Let's say its dimension is m by n. Suppose its dimension is n by n. So like A is having dimension of m by n. So definitely B must be having dimension of starting from column n by p, right? So if we understand it, like first one is having dimension m by n and second is having n by n. So multiplying these matrices will take m, n and p, m dimension m by p, right? And its time complexity will be m, n, p, right? So suppose if n and suppose if m equal to n equal to p, so its time complexity will be equal to n cube. If we assume that m and n and p equal and it is equal to n. So like it is cubic in time, so it's like not a small time. So this is the matrix multiplication time complexity. Right, so this is the method Aik into Bkj. Cij is actually Aik times Bkj, k ranging from 1 to n. So we must compute n by n matrix entries, and each is the sum of n values. After this like multiplication, we are adding them together. So overall time is going to be n cube. So this is square matrix multiplication. We know that n is number of rows, or you can say it is number of column, and C be any n by n matrix, right? So we know that this is the we run I loop and j loop, and then Cij is 0. K is ranging from 1 to n. So Cij will be Cij plus Aik into Bkj, right? So actually its running time is going to be theta n cube. Why? Because if you look at here, its time is like theta n, okay, and its time is theta n square, and since it is within this, so this will be theta n cube in this discussion. If you are not like going to discuss its time by this way, if you just think about it, its running time, its testing time will be n plus 1, and this guy, its testing time is n plus 1. Of course its running time is n plus 1, and this is going to be executed n times, right? So this is going to be executed n times, since this is body of the outer loop, okay? So now if you talk about running time of this loop, this is like n, and its body of it is body of this loop, so it is going to be n plus 1, okay, its running time is n plus 1, its body is here, it is body of this, its time is n, okay, and then this is again body is of this, so its time will be this. So same thing here, it is body of its time is 1, okay, and this is body of this loop, so its running time is n, and again this is body of this loop, its running time is n, and now this is body of this loop, it is running time of this. So overall if you sum it together, still you will get theta n cube. So in general running time is going to be theta n cube. So this is not very much recommended method of multiplying two matrices of order n by n. So so there is method of divide and conquer, we call it recursive matrix multiplication, okay. So what they have done, they are just like if you are going to multiply two matrices, generally we are assuming that A is n by n and B is also n by n, okay. So overall resultant matrix will be C will be n by n, clear. So in divide and conquer approach, what we will do, we will divide this matrix of n by n into n by 2 cross n by 2, n by 2 by n by 2, okay. So generally this, instead of two matrices, we are going to divide them into the 4 matrices. See, we make this assumption because we are assuming that n is integral power of 2. In this recursive multiplication, we are assuming that n is integral power of 2, right. We make this assumption because in each case step we will divide n by n matrices into 4n by 2 cross n by 2. This is the assumptions. Let's see how it will work. Suppose, you know, if you want to divide, let's say this matrix, this is number 1, this is number 2, right. So suppose we are taking 1 2 3 4, 1 2 3 4, right. So let's say 5 6 7 8, 5 6 7 8. So this is my one matrix of 4 by 4, clear. This is one matrix of 4 rows and 4 columns. So if you just divide this by 2 by 2, 2 rows by 2, again this is 2 by 2, 2 by 2. That means this is n by n. So individual matrices can be 2 by 2, right. 2 by 2. Same thing, this is also 2 by 2. Same thing, this is also 2 by 2, right. So if you can multiply, you can simplify them and then multiply, we will be thinking that time will be reduced, but it is not actually happening, right. So this matrix is n by 2 cross n by 2. Same thing, this is also n by 2 cross n by 2. So instead of 2 n by n matrices, we are having 4 n by 2 cross n by 2 matrices. There is no effect on the result. Result is still going to be the same. There is no effect on the result, you know. So so is there any improvement, okay. So see this, suppose that we partition each of A, B into C 4n by 2. This is 4n by 2 matrices, clear. So here A11 is 4n by 2, this is n by 2 cross n by 2. This is also n by 2, this is also n by 2 cross n by 2, right. All the individual A11 is nothing but this is n by 2 cross n by 2. So all the individual matrices, they are still having n by 2, n by 2. So if you multiply them together, look at here, you see this is the multiplication. We divided 8 by 8 like 4 by 4 into this way, right. So still if you just multiply them, A11 B11, okay, plus A12 B21. This is the first one, C11, first row, first column, okay. Second one, first row, second column, okay. So A11 B12 plus A12 B22, right, yes. Second row, first column, okay. So A21 B11 plus A22 B21, okay. C22 is A21 B12 plus A22 B22. This is 4 matrices. So how many multiplication do we have? We have 8 multiplication, 4 here and 4 here. So, and addition is also going to be performed. So, we know that matrix addition is going to take theta n square time, because we are just having two loop, like see, just like running two loop, and you will see that addition is going to get theta n square, just like here addition is also going to take part here, right? Okay. So, still that means still we have 8 multiplication. So, overall time will be how much? Tn will be like, you have 8 multiplication. So, this is 8 Tn by 2, right? Individual matrices of size n by 2, we know it, like if individual matrices are having n by 2 size, plus their addition is going to take theta n square time, right? So, by master method, like so n square is big O of n power log of a, just compare with the master method. Tn is a Tn by b plus Fn, okay. So, if you just compare Tn this one, and we know that case 1 of master method is if Fn is theta big O, if Fn is big O of n to the power log a, right, base b minus epsilon, where epsilon is greater than 0. In this situation, Tn will be theta n to the power log a base b. This is the solution, okay. So, here if you look at here, n square is this Fn is n square n to the power log a is 8 and b is 2 minus epsilon, yes. So, if you look at here, n square is big O of n to the power log this 3 minus epsilon. Of course, you can take epsilon equal to 1. So, that means case 1 is applicable. So, by this case 1, its running time of this recurrence will be Tn is theta n to the power log a is 8 and b is 2. So, this is going to be theta n cube. This means there is no improvement, even using divide and conquer approach, we are not getting any further improvement, right? So, it remain as it is. So, Stressen suggested a method like to reduce the time, to reduce the multiplication. This is very like good method. Suppose we have matrices like A11, 1, 2, 2, 1 and 2, 2, and same thing B11. This is also another matrix, right? So, how to multiply these two matrices, and we also assume that C is the matrix which is going to get C11, 1, 2, C21 and C22. These individual matrices can be n by 2, can be n by 2 by n by 2, or it can be any matrices. It's not very important. So, method will work for any type of matrices, right? Yes. So, what we are assuming, that we are assuming for this one, we are assuming this this auxiliary method 1 1 1 2 2 1 and 2 2. This is the assumption, right? Yes, okay. So, what we are going to have, like we are going up for P, it's very simple. We are going to have individual components, 7 components, 7 P Q R S T U V. What is P? We are just taking the diagonal. P is A11 plus A22 times B11 plus B22. This is the diagonal. P is very simple to remember. Diagonal, just take diagonal 1 1 2 2, 1 1 plus 2 2, B11 plus B22. P is clear. For QRST, we are going to take the help of this construction 1 1 1 2 2 1 2 2. And for this computation QRST, we are going to take help of Bob. We are going to take help of Bob, right? So, here is like you just 1 1 1 1, then 2 2 and 2 2. Yes, we remember, like see 1 1 1 1 and then 2 2 2 2. Bob, we just remember Bob, right? And this is taking the help, this is guiding Q, right? And this is guiding T. This is guiding T, QT, QT. If you are going in this direction, it will be plus. Going in this direction, it will be plus, right? And this is going to be plus, this is going to be plus. If you are going in this direction, this is going to guide R, and this is going to guide S. It is also going to be negative, this is also going to be negative. How to remember? Just like north south, so this is opposite of the south, north south east west, right? So this guy's S is going to be opposite of the normal south, and this R is in this right down direction, right? So if you just remember this, this is going to guide about Q, R, S, T. Okay. So how to get Q? Look at here. We'll take the help of Bob. For Q, it is in positive side. Look at here. So first, if you take B11, okay. So inside should be opposite. You know, if this is B11, we have taken B11. Yes. So inside should be opposite. And what is Q? This is 2122. So A21 plus A22. This is correct. This is the Q in construction. If you go to then R is like here. P, Q, R, S, T. Q, R, S, T. This is what we are remembering. R means like next is A. R, A11. Yes, A11. So opposite, like inside should be B. B12 minus B22. That is it. Simple. B12 minus B22. In order to get S again, right? So Q, R, S. Yes. This is yes, opposite of the south. Okay, opposite of the south. So this is A22. Outside is A22. So inside will be opposite of A. That means B. So it is like B21 minus B11. This is simple, right? B21 minus B11. Okay. And now if you look at the T, this T is here, right? And for T, we are going to consider B22. Very simple, B22. So T is going to be inside is A11 plus A12. This is simple. This is simple construction to remember, right? This Bob is very helpful to compute the QRST. Okay. So we are done with this intermediate matrices. We are done with this intermediate matrices. So how to compute U and V? U is being computed from S and T. S and T. U is computed from umbrella, is computed from S and T. So we are not going to consider them. We are not going to consider them. We are just considering the parenthesis. Just change B to A and A to B. So here will be A21 minus A11 times B11 plus B12. That is from S and T. Similarly, V is going to be computed from Q and R. Just to change the we are only considering parenthesis, change A to B and B to A. So here will be V, B21 plus B22, okay, and then A12 minus A22. That is computed. All these 7 individual matrices are being computed. P, Q, R, S, T, U and V. Clear? Okay. Now, after computing Q, R, S, T, U, V, it's now time to compute C11. Okay. So, C11 will be P plus, you know, P plus, P is there, P plus S minus T plus V, right? This is the, just to remember, P plus S minus TV. You know, you can assume that, yeah, P plus S has no TV. Okay. So this is C11, and then C12. For C12, we remember right. Okay, right. A stand for plus, addition, and R and T. So R plus T, this is like right. Okay. So this is C12. Now its next time is C21. Just like you assume that right is going in one house before, right? So if we assume that this is right, so we are right has entered one house before. So so before r is q, right, and before t is s. So this is going to be q plus s. Yes. By this one assumption that rat has not entered into the correct house, it has entered one house before. Okay. So now if you look at C22, C22 is nothing but coming from the C11, right? So this is P C11. So C11 is like P plus S. So C22 will be P remain here, and in place of S we just take this connection. We take this connection. In place of S we write R, and in place of T we write Q. Okay. And the last one, since U have not been used before, we just write capital U. So this will be P plus R minus Q plus V. So after computing all this one, you will get the matrix, you will get the correct answer. Let's have one example. Suppose this is like A matrix. Suppose this is your A matrix. Okay. And this is B matrix. So let us compute P. P is this. Same method we are using. So this after computation, it is giving 16. So apply Q B11. B11 is minus 7, and you see 821. 821 is minus 4 plus 3. This is 7. After just computing individual matrices, right, you will see that C11 is giving minus 5, and C12 is 84, C21 is 43, C22 is 9. So you know, like C11 you are going to get minus 5, and C12 is 84, C21 is 43, C22 is going to be 3. We can compute it without matrix, without Strassen's also. Look at here, just to verify one. C11 is first row, first column. So 5 times minus 5, sorry, minus 7 plus 6 times 5, right? So minus 35 plus 30, it is going to be like minus 5, which is correct, right? So look at here. So what we have gained so far, you know, number of multiplication is 1, 2, 3, 4, 5, 6 and 7. So we have done 7 multiplication. So this is going to be 7, and number addition is still going to be the same. Addition is not impacting too much on the time complexity. It is still n square. So by the same method, you will see that n square is big O of n to the power log 7 base 2 minus epsilon, which is correct. So running time is going to be theta this, and this is actually value of log 7 base 2, right? So that means we have gained little bit, like from n cube, right? It is giving n 2.87. So of course this is lesser time as compared to normal multiplication. So these are the references like Thomas Kuhlman, Introduction to Algorithms. You can follow it.